Domain of function. So, as we've already said, the domain of a function is the set of numbers or elements that represents all the input values for which the function is defined. Most commonly, the variable that we use to represent our domain is the variable x. That's what we plug in. The domain of a function can be stated explicitly, or it can be implied by the expression used to define the function. Here we have the function f of x is equal to 3x cubed minus 7x plus 10, comma, x is greater than or equal to 0. In this particular case, notice we have this x is greater than or equal to 0 next to the function. Here they are explicitly telling us that we are only talking about values of x that are greater than or equal to 0. This is a definition of an explicitly stated domain. Here we have the function g of x is equal to 1 over x. Now notice there is no explicitly stated domain next to this function. However, the domain is implied that x cannot equal 0. As you may recall, we cannot divide by 0. Doing so causes a function to be undefined. So our domain in this case would be all real values of x with the exception of x equals 0. So, finding an implied domain algebraically. To find implied domains of algebraic functions, there are two major rules that you have to remember. Rule number 1, the denominator of a function cannot equal 0. And rule number 2, the value inside of an even root must be greater than or equal to 0. Recall that we cannot take the square root of a negative number. We cannot take the even root of any negative number. That means if it's not negative, it has to be greater than or equal to 0. So, to find our domain, we want to determine which rule or rules apply to the particular problem and translate the rule into a mathematical expression. Now notice I've used the word translate, okay? We are going to take an English sentence and rewrite it as a mathematical expression that will allow us to find our domain. Let's take a look at an example. Find the domain of the following function. F of x is equal to 4x plus 7 divided by x squared minus 2x minus 8. Well, let's determine which of the two rules we're going to have to worry about here. Since there are no radicals or even roots, we don't have to worry about having a negative value inside of an even root, right? But we do have a fraction. So what we do have to consider is the denominator being 0. As we know, based on our rule, the denominator of a function cannot equal 0. Now, we need to translate this sentence into a mathematical expression. The first part of the sentence says the denominator. Well, literally speaking, what's the denominator of this function? The denominator of the function is x squared minus 2x minus 8. What can't happen? It cannot equal 0. In mathematics, we use an equal sign with a slash through it to represent cannot equal, which leaves us with the expression x squared minus 2x minus 8 cannot equal 0. Now we can solve this just like we would any normal quadratic equation. And to do that, that's going to require us to factor. In this case, our quadratic factors into x minus 4 times the quantity x plus 2 does not equal 0. And just like we would with our normal quadratics, if that were an equal sign, we are going to set each of the factors, in this case, not equal to 0. So I have x minus 4 does not equal 0, and x plus 2 does not equal 0. Continuing to solve the equation for x, each of these equations for x, I now have x cannot equal 4 and x cannot equal 2. This tells me that my domain is all real values of x slash x cannot equal negative 2 or 4. This fancy looking R with two bars on the left-hand side means all real numbers. To write our answer in interval notation, we would have parentheses negative infinity comma negative 2 in union with negative 2 comma 4 in union with 4 comma infinity. Notice that in this case, our interval notation has parentheses around each of these values of x because these endpoints of each interval are not included, right? We're talking about values of x from negative infinity to negative 2, and then we have a gap. We have values of x from negative 2 to 4, and then we have a gap at 4, and then values of x from 4 to infinity. There we have our interval notation. If you have any questions on interval notation, make sure you reach out to me if you haven't used it before. All right, let's try another example here. Find the domain of the following function. G of x is equal to the square root of negative 3x plus 5. Well, again, we have our two rules. 1, we can't divide by 0, and 2, we can't have a negative inside of an even root. The value inside of an even root must be greater than or equal to 0. Since I don't have any fractions where the denominator could potentially be 0, but I do have a square root, the second rule is the one that we're going to have to pay attention to. The value inside of an even root must be greater than or equal to 0. So to find our domain, we must translate this sentence into a mathematical expression. Notice the first part of the sentence says the value inside of the root. The value inside of the root. Well, literally speaking, what is inside of this square root? There is a negative 3x plus 5 inside of the root. And what has to be true about that value inside of the root? It must be greater than or equal to 0. So we are able to set up this inequality. Now, to solve this linear inequality, we can begin by subtracting 5 from both sides. And to isolate x, we can divide both sides by negative 3. Now remember that when you divide by a negative or multiply by a negative in an inequality, that means that the sign is going to flip. In other words, this leaves us with x is less than or equal to 5/3. This tells us our domain right here. Okay, again, note that the inequality sign flips when multiplying or dividing by negative numbers. Our domain, all real values of x, x is less than or equal to 5/3. To write our answer here in interval notation, we want to include all the numbers that are less than or equal to 5/3. That would be from negative infinity to 5/3. Notice that we have a bracket around the 5/3 as opposed to a parentheses, as the bracket indicates that that endpoint is included in the domain. 5/3 is part of the domain. And one last one here. Find the domain of the following function. H of x is equal to the square root of x plus 6 divided by the quantity 3 plus x. Well, in this case, we've got a square root, and we also have a fraction where the denominator could potentially be 0. So let's start off with our first rule. The denominator of the function cannot equal 0. Well, what's the denominator? The denominator is 3 plus x. And so what are we going to say? That 3 plus x cannot equal 0. Solving this equation for x tells us x cannot equal negative 3. Now, let's look at our second rule. The value inside of an even root must be greater than or equal to 0. Well, what's inside of our square root here? The value inside of our square root is x plus 6. And what has to be true about x plus 6? It must be greater than or equal to 0. Solving for x gives us x is greater than or equal to negative 6. Now, to find our domain, both of these criteria must be met. Okay, our values of x must be greater than or equal to negative 6, but also x cannot equal negative 3. All right. This means that our domain is going to be all real numbers. X is greater than or equal to negative 6, and x does not equal negative 3. If we were to write this in interval notation, however, our solution would be bracket -6. Notice the bracket because -6 is included. I then have values of x from -6 to -3 with a parentheses in union with -3 to positive infinity with parentheses. Notice that I have this gap at -3 because, as we said, x cannot equal -3. All right, so in this particular case, we had two rules, both of which had to be met. There is finding domain of algebraic functions.